Cool. So we are good to go. So today's talk is about introduction to versioning systems and Git. So we chose this topic because this is a very crucial topic. Let's say that if you are into cricket, and it's as crucial to cricket as being able to catch and throw the ball, right? So software is all about collaboration and iteratively developing software, and knowledge of Git is kind of necessary for those kind of things. Okay, so let's get started. So what is version control? Basically, version control is time travel over file system. So uh, I hope you are aware of which movie scene is this. Which one? Interstellar, right? So version control is time travel over file system. So our operating system already provides us ability to abstractions called files, which is a very high level layer over storage devices as well as memory. So we already have the ability to move from one folder to another. We also have the ability to go down into child folders or move up to parent directory. So we have that capability, but that is not enough. What we also need is basically not only we want to land up in a folder, we also want to know what the content of the folder was at particular point of time. So हमें टाइम ट्रैवल करना है फाइल सिस्टम पे, और ये हमारा शौक नहीं है, ये हमारी ज़रूरत है. आगे चल के हम देखेंगे कि इसकी ज़रूरत क्यों पड़ी हमें. Why do we even need to be able to find out how a folder or a particular file looked at a particular point of time. So today we'll talk about Git, and Git is a particular version control system. So what is version control system? It is a tool that helps us track how a particular project changes over time, or how it looked like at a particular point of time. Version control system ये करता है, और not only it applies on your code, but it also applies on simple text files, binary files, or PDF files. It applies to any kind of file. So let's this is the history. We'll be going through this history before we move on to Git, because in this history lies certain ideas that we can apply to certain other things, and ideas that are still surviving in current version control systems. So it all started in 1972 when Mark Rochkin came up with SCCS. SCCS is Source Code Control System. Okay. All the version controlling systems that we are going to talk about today, they are roughly categorized into three generations. First generation was local version control system, where on your local machine you can track changes in the file. Second generation came up with centralized version control tools. This is like a first effort where you want to not only track changes but also do collaboration across geographical boundaries. So people sitting in India can collaborate with people sitting in Europe. So second generation version control systems came up with that feature. And then there was third generation, which was distributed version control systems. We'll talk about them in detail. So let's start with the history. Before SCCS came, what people used to do to share code. Why sharing of code is necessary? Because anything great requires collaboration, requires feedback from multiple people, and that makes it necessary for us to share the source code with other people. Okay, that is one thing. Second thing is that as our software evolves, there is a need to revisit previous versions of softwares. Let's say something broke in my code, I would want to go back to the point of time where it was working properly, right? So this going back and forth is kind of a necessary thing for software developers, right? So what people used to do before is they used to zip their folder and share it with other people, right? And they used to unzip it. Then all sort of headaches used to happen, right? I have to compare what other person has coded with my version. I need to see what I have added, they have removed, all those kind of things. And that was kind of an extra overhead. So more time was going into fixing these collaboration things than actually targeting the problem at hand, right? So this was something people were facing beforehand. Let's say that we have so what people used to do is they used to code up, they used to zip that folder and name it something like with date timestamp, that at this date this was the content of the code base, right? And they used to maintain multiple copies, and they used to share also with other people. Now the problem was that even though we have the exact state of the code base, we can't find out how it is different from what we are doing currently, right? And why we made that change, all that things were not accessible to us, right? So that's why a quest started where we wanted to do time travel over our code base. SCCS was first attempt, which was we started in 1972 at Bell's Lab. Uh, as you know, Bell's Lab is a birthplace of lot of different things in computer science, and version controlling is one of them. So, what are the key ideas that came up with SCCS? So, number one was that we are able to track version of each file. So, how it is undergoing change through the time, we are able to track that. Okay, so that is one thing. Other idea was checksum. So it used checksum to ensure file integrity. Now, what is checksum? Let's say you have a file and you are sharing it with someone, okay, and you want to ensure that other person is getting the same file that you shared without any corruption. So what you do is you kind of hash the content of the file, and it leads to a number, checksum. Okay, so now along with the file, you are also storing and sharing this number, checksum. Okay, and if there is and when you are using this file, you are again calculating the checksum, and that checksum should match the checksum that is shared with you. And by doing this, you are able to maintain the integrity of the file that is under consideration. Second thing is delta. So as we discussed before, version controlling, people used to store the entire code base, okay, and version them by timestamp or something, right? But that is kind of a redundant exercise. How it is redundant? Because projects evolve over time and then they undergo changes, right? So instead of storing the entire code base, what do we do? As project undergoes changes, we just store the differences. Okay, so initially we have a certain state, and then next time when we want to create a version of the project, what we do is we just store the delta, the differences that uh, project have incurred since last time we last version, right? Now this delta is ubiquitous in computer science. So if you heard about PNG, it's a file format, right? It compresses the image. How it compresses the image? Rather than storing each pixel, it starts storing the differences, right? So as you can see on screen, if you want to store this image, right? So most of the pixel are same, right? You don't go through abrupt changes in an image, right? So what if instead of storing the values of the pixel, you start storing the differences, right? So only first pixel over here like will be stored, and then what are the rest of the values? 000. Why? Because no change, right? Then some alphabet is coming, then there is a drastic change, and you are storing that number, difference number, right? So that's how delta is kind of useful across, right? Instead of storing large numbers, you are storing most of them will be zero because image doesn't go abrupt change, right? So we are moving from storing large numbers to small numbers, yet we are able to restore the entire image, right? So same thing is with delta. By storing the differences that your project is going from version to version, you are freed from the necessity to save the entire project, right? Changes are minor. You just store the changes, and then you just do some like in PNG we do add subtract, right? Here we also do we apply delta over a file, and that will lead us to any of the version that we want to reach, right? So there are different kind of delta algorithms. What SCCS used to have is interleaved deltas. Okay, let's look at one of the history file of SCCS, and that will give us clear idea about how interleaved delta works, right? So this is one of the history file. So file name is file.md, and what SCCS does is it creates another history file for file.md with s prefix. Okay, so you are able to see this. Now this first number is basically what? Checksum. Okay, checksum calculate kahan se hota hai? From the next line, because it's not possible to calculate checksum including the checksum itself, right? So it has to have something, and then that number is added, right? So that's why this is checksum from the second line. Okay, this is used to maintain the integrity of the file. Let's say that I manually edit this file. What will happen? It will change the actual checksum, and when SCCS operates on it, it will compare that checksum with this, and it will find that some corruption has happened, right? And it won't operate on this. So that's how SCCS maintains the integrity of history files. These are the commits. So I created this file that was like first commit, then there is second commit, and then there is third commit, right? So think of commits as different point of time which I can go through in this file, right? Now, how I edited this file is, at first I inserted this line, this is first version, okay, and then I committed it. Okay, so how you are looking at it over here is that AI1. So this is the commit number, and what it does was insert this line. Okay, now what I did was in second comment was second comment inserted this line. This is the second version. Okay, and then what third commit did to this is it deleted this line and it inserted this line, right? So these are interleaved deltas. What is happening is that the deltas are not separated, right? In one file only, what each commit is doing to a particular line, it is stored line by line, right? Now let's say that if I want to go to commit number 2, what will happen? It will execute all the delta operations before that for commit 2 and 1, and what will be ending up is this is first version, this is second version. And currently, if you look at what our file looks like, so this will be this, right? First version added in first commit, then second version was added in second commit, it got edited, and now this is the final state, right? So this is what interleaved delta is about. इंटरलीव डेल्टा से हमें फायदा ये होता है कि कोई भी वर्जन रिट्रीव करने के लिए मोर और लेस सेम टाइम लगता है. ओके, सो दैट्स द एडवांटेज ऑफ interleaved deltas. Let me put the battery. Okay, so now this was back in 72, right? After 10 years came the next version control system, which was written in C by Walter Tichy. और ऐसा करने की जरूरत उनको इसलिए पड़ी क्योंकि SCCS was not open source, right? It was closed source, Unix में आता था, और इसलिए उन्होंने इसका ओपन सोर्स वर्जन बनाया. और इसमें जो की आइडिया था वो रिवर्स डेल्टा का था. सो व्हाट इज रिवर्स डेल्टा? बेसिकली इंटरलीव डेल्टा में क्या होता है, हर एक लाइन में किस कमिट ने क्या चेंज किया वो सारे डेल्टा हम स्टोर करते हैं, राइट? रिवर्स डेल्टा में क्या होता है कि जब भी हम कोई कमिट करते हैं तो जो लास्ट वाला जो वर्जन है वो हमारा सोर्स ऑफ ट्रूथ हो जाता है. ओके, और हम पिछले वर्जन्स पे जाते हैं बाय अप्लाइंग डेल्टा. Okay, so think of it this way: rather than in a PNG image, rather than considering the first pixel as the base, we are considering final pixel as the base, and then पिछले pixel access कर रहे हैं by doing applying some delta, right? So and RCS didn't use checksum, so it was kind of it had a risk of applying like corrupting the file. Now let's look at RCS ka history file, and that will make us clear what reverse delta looks like, right? So okay, so this is what RCS file looks like. हम ये जानना चाहते हैं कि रिवर्स डेल्टा कैसा दिखता है, राइट? सो सो लाइक वी टॉक्ड अबाउट कि पहले क्या होता है, कमिट्स होते हैं सारे, राइट? एंड आरसीएस ये इंश्योर करता है कि एक बारी में एक ही बंदा उसको एडिट कर पाए फाइल को, राइट? तो जो भी बंदा उसको एडिट कर रहा होता है वो उसको लॉक कर लेता है, राइट? सो आरसीएस इज अज्यूमिंग दैट मल्टीपल पीपल will logging into the same machine via different logins on a Unix system, and to stop multiple users to act on the same file, what it does is जो भी बंदा SCS RCS के थ्रू फाइल को एक्सेस करता है उसका लॉक लग जाता है और बाकी लोग उसको एक्सेस नहीं कर पाते उस दौरान जब वो एडिट कर रहा है RCS से. This is the description of the commits. So like first commit 1.1 timestamp, right, followed by 2 more commits. Now this file undergoes same changes which the previous file went, right? First commit जो है this is first version add करता है और second commit जो है this is second version add करता है, third जो है उसको replace कर देता है second line को this से, right? Now we talked about this is reverse delta. So क्या है हमारा source of truth क्या है? This is equivalent to what is the file state currently, right? अब हम इस पे डेल्टा लगाते हैं. सो डेल्टा क्या कर रहा है? सेकेंड कमिट पे जाने के लिए हमें क्या करना है? दिस लाइन डिलीट, राइट? एंड देन वी हैव टू ऐड दिस लाइन. सो बाय अप्लाइंग दिस डेल्टा वी आर एबल टू रीच द प्रीवियस थिंग. नाउ फर्स्ट वाले को क्या करना है? डिलीट फर्स्ट लाइन. ओके, I think it will also have to delete the सिर्फ फर्स्ट जो सेकेंड लाइन है उसको डिलीट करने से we get the first version. This is the first line, right? So this is about reverse delta. Reverse delta का फायदा ये होता है कि since हमारा जो लास्ट करंट वर्जन है that is the source of truth, तो जो recent रिविजन्स होते हैं कम डेल्टा अप्लाई करने पे हमको मिल जाते हैं. तो recent versions जो है faster हो जाते हैं to access. We can check out any of the recent version faster, but as we want to go retrieve the older versions, what happens? You have to apply more deltas and that becomes a little slow, right? So there is a trade-off here. SCCS में क्या था, हर कोई equal time देता था. ये क्या करता है, reverse delta का use करके जो recent versions होते हैं वहाँ तक फटाफट पहुँच जाता है, but पुराने versions में हमें और ज़्यादा मेहनत करनी पड़ती है because there are more deltas to be applied. दूसरा ट्रेड ऑफ ये है कि जब भी हम कोई नया कमिट बनाते हैं तो पूरा हिस्ट्री फाइल जो है रिमूव होता है और फिर से हम डेल्टा कैलकुलेट करते हैं, राइट? ऐसा करने की जरूरत क्यों है? बिकॉज हमारा सोर्स ऑफ ट्रूथ ही पूरा चेंज हो गया, राइट? नाउ एवरी कमिट विल रिक्वायर डिफरेंट डेल्टास टू अराइव एट दैट पर्टिकुलर कमिट, राइट? सो दिस इज मोर राइट हैवी ऑपरेशन, बट हमारा रीड जो है इजी हो जाता है, स्पेशली फॉर द कमिट्स विच आर recent. So this is about RCS. Before we go into second generation, do you have any doubts so far? Okay, so let's move back. अब आता है सेकेंड जनरेशन, राइट? सो अभी तक क्या था ना कि एक ही मशीन पे अगर कोलैबोरेशन हो रहा है तो ये दोनों कर पाते थे उसको, राइट? हमने मल्टीपल कोलैबोरेशन देखा था पिछले RCS में, वो किस तरीके से कि मल्टीपल यूजर्स एक ही सिस्टम में लॉगिन करके वो फाइल एडिट कर पा रहे थे अलग अलग टाइम पे, राइट। बट वो हमारे लिए काफ़ी नहीं था। दो चीज़ें मिसिंग थी। एक तो ये कि collaboration was restricted to one particular machine, right? Which is not always the case. Everyone wants to work on their own machine, have their own setting and all that, right? So एक geographical boundary था जो हमें पार करना था, तो वो सेकेंड जनरेशन ने हमारे लिए किया, राइट। सो इट वाज क्रिएटेड बाय डिक ग्रून in 1986. So if you see the time, this is like 1972, 82. After 4 years, we came up with CVS. CVS added networking element. So they are like machines when they are on different geographical locations. If you are able to access each other via network, they should be able to collaborate. Okay. अब इसका खासियत ये था ना कि ये बैकएंड जो है RCS का ही यूज कर रहा था. अंडर द हुड इट वाज यूजिंग RCS कमांड्स, बट उसके ऊपर एक रैपर था which was CVS, right? And CVS allowed the networking aspect of this thing, right? Key ideas was कि अगर मल्टीपल पीपल को शेयर करना है, कोलैबोरेट करना है किसी भी चीज़ पे, तो एक सोर्स ऑफ ट्रूथ चाहिए हमें, राइट? सो वो सोर्स ऑफ ट्रूथ कहाँ किसकी मशीन पे रहेगा, उसका सोल्यूशन ये निकाला गया कि हमारे पास एक सेंट्रलाइज्ड रिपोजिटरी रहेगी जिसको सब देखेंगे, राइट? जिस पे सब पुश करेंगे, जहाँ से सब पुल करेंगे. So that was the key idea behind it, breakthrough idea, and that helped us to traverse the geographical boundary for the first time, right? So that was about CVS. Then came Subversion. This was kind of a more latest thing, and I'm sure some of the people will also remember it. So ये 2000 में बना कोलैबनेट इनकॉर्पोरेशन से, और अभी currently it is maintained by Apache. So there are a lot of projects that Apache maintains. Apache web server, all that, right? So all these open source projects, I think अभी PyTorch भी जो है Apache is maintaining. Right. I'm doubtful, but recently there has been a development. So अभी इसके key ideas discuss करते हैं. वो क्या थे? हमने देखा कि जो CVS है, कंकरेंट वर्जन सिस्टम, वो नेटवर्क इम्पैक्ट लेके आया, राइट? बट उसमें दिक्कत ये थी कि मान लो आई एम पुशिंग समथिंग टू द सेंट्रलाइज्ड रिपोजिटरी एंड माय नेटवर्क गेट डिसरप्टेड, राइट? सो देयर वाज अ पॉसिबिलिटी दैट इट लीव्स द सेंट्रल रिपोजिटरी इन अ करप्ट स्टेट, अनयूज्ड, एंड वी हैव टू अबैंडन इट, राइट? सो सबवर्जन में पहली बार एटॉमिक कमिट्स का फंडा आया. या तो एक कमिट पूरा से पूरा एग्जीक्यूट होगा, या फिर वो टोटली डिस्कार्ड होगा और हमारा जो सेंट्रल रिपोजिटरी है सेम सिचुएशन में रहेगा जैसे पहले था, राइट? सेकंड थिंग वाज फाइल सिस्टम अटॉप द फाइल सिस्टम. सो सबवर्जन जो है जिस भी OS में डाउनलोड होता है या इंस्टॉल होता है, उसमें वो उसी का फाइल सिस्टम का स्ट्रक्चर उठा के उससे कंसिस्टेंट एक और फाइल सिस्टम उसके ऊपर बनाता है. And that is like the time aspect of it. Okay, so I'll again bring interstellar analogy over here. When Matthew McConaughey end up in the singularity, right? So he was able to access the room of his daughter at different points of time, right? But he was a 3D being, right? He was not 4D. वो time travel करने में सक्षम नहीं था. तो future human beings ने क्या किया कि अलग-अलग rooms बना दिए, और अलग अलग रूम्स क्या है, बेसिकली डिफरेंट सिचुएशन ऑफ दैट मर्फीज रूम एट डिफरेंट पॉइंट ऑफ टाइम, राइट? सो कुछ इसी तरीके का जुगाड़ यहाँ पे भी हुआ है. वी आर 3D बीइंग्स एज फार एज फाइल सिस्टम इज कंसर्न, राइट? बट वी आर नॉट एबल टू डू टाइम ट्रैवल, राइट? सो वो भी नहीं कर पाता था, बट हमने कुछ ऐसा किया कि जस्ट बाय वॉकिंग फ्रॉम वन प्लेस टू अनदर दैट पर्सन एंडेड अप इन अ डिफरेंट टाइम, राइट? मूविंग बैक एंड फोर्थ. सो वो फिजिकली मूव कर रहा है, बट एक्चुअली वो टाइम ट्रैवल कर रहा है, राइट? सो हमारे OS ने भी हमें टाइम ट्रैवल की सुविधा दी नहीं है, बट फाइल सिस्टम में वी हैव ऑल द फ्रीडम, एंड व्हाट वी आर डूइंग बेसिकली इज क्रिएटिंग अनदर एब्स्ट्रैक्शन ओवर फाइल सिस्टम दैट गिव्स अस अ फील ऑफ टाइम ट्रैवल. सो वो सबवर्जन जो है लेके आया Another thing that subversion brought is compression. So अभी तक क्या था कि हमने RCS में देखा, SCCS में देखा, CBS में RCS का बैकग्राउंड बैक एंड यूज होता है, तो there was no compression aspect, right? There was like text file में हमारा पूरा history store हो रहा है, and it lead to when the project size becomes large, space also occupation also becomes large. So SVN first time brought the funda of compressed delta. So delta जो है compressed form में store होने लगे, और it was more convenient, right? So उतना ड्रास्टिकली विद प्रोजेक्ट साइज हमारा जो बुक कीपिंग वाला डेटा है वो इंक्रीज नहीं हुआ. That was first time happening in SVN. Now let's come to Git. Git came very late into the party in 2005. Okay, and it was developed by Linus Torvalds. Linus Torvalds is creator of Linux, right? And कर्नल कोड मेंटेन करने के लिए उनको सहूलियत हो, इसलिए उन्होंने क्या किया, Git बनाया, right? Because he was maintaining kernel code for a long time, and was actively maintained by kernel developers all across the world. So that's why he just stitched some C code with shell script, or we got Git. So Git was the key ideas that came with Git is, number one is कि distributed version control. So CBS हो गया, SVN हो गया, they require they are centralized solutions. Centralized solution in the sense कि हमारे पास एक centralized repository है, the single source of truth, and everyone is like looking at it, right? Git ने क्या किया, इसको decentralize कर दिया. Now no more there is one source of truth. All the people who are collaborating, anyone can be a source of truth, right? Because everyone is having the latest copy of the code on their machine, so it can be so it was more distributed and it was decentralized. Second thing, key idea that came with Git was that they started taking snapshots instead of deltas. So rather than हर एक फाइल का डेल्टा स्टोर करने के और उसको डेल्टा से वर्जन्स पे जाने के, they started storing snapshots. Now this might lead to too much space being used, right? So उसको उन्होंने कैसे सॉल्व किया? They applied certain techniques. Compression was one of them, right? Second thing was content addressable storage. So what is content addressable storage? Whatever file का जो content है उसके basis पे उसको hash करते हैं, right? और वही उसका identity बन जाता है उस file का, right? So let's say that we want to detect कि कौन सी file में change हुआ है, कौन सी file में नहीं हुआ है. Just by looking at the hash, we'll be able to figure out this file underwent changes, this file didn't underwent any change, right? So this was another aspect. Git का फंडा जो है बहुत इंटरेस्टिंग है, and I have shared the internals, like you can explore the internal how Git works in one of the links found in references. This idea is basically ubiquitous, आपको हर जगह मिलेगा वो. If you have used Google Docs, then there is this versions, right? आप एक Google Doc के किसी भी version पे आप जा सकते हो, right? So there is some sort of versioning happening over there. Amazon S3 that also provides versions, so you can actually retrieve any version, previous version of a file that is stored on S3. So this is a very interesting computer science problem, and if you are interested in exploring it more, I encourage you to explore the source code of this. They are like C code bases, RCS, SCCS, SVN, right? And since they are old, they must be simple also. So please feel free to explore them. It should be a good intellectual exercise. अब बात करते हैं Git की. So let's look at this diagram, and based on that, हमारा जो बाकी का डिस्कशन है वो कंटिन्यू होगा, राइट? सो पहली चीज ये है कि हमारे पास एक प्रोजेक्ट है जिसको हमें ट्रैक करना है, राइट? दैट प्रोजेक्ट इज बेसिकली आवर वर्किंग फोल्डर, ओके? देन देयर आर सम पार्ट्स जिसको हमें ट्रैक करना है, राइट? जिसका हमें पूरा हिस्ट्री मेंटेन करना है कि वो किस तरीके से इवॉल्व हुआ उसकी अपनी करंट सिचुएशन में, राइट। वो है हमारा लोकल रिपोजिटरी। इसके बीच में आता है क्या, एक स्टेजिंग एरिया आता है जो हमारा वर्क इन प्रोग्रेस है। ओके, सो व्हाट आई विल डू इज आई विल क्रिएट अनदर फोल्डर फ्रॉम स्क्रैच and we'll go through how we move from one place to another. Okay, so this is my empty folder. Okay, अब मैं इसमें डेवलपमेंट करना चाहता हूँ and I want to keep track of the objects that I build here, right? So what I'll do is I'll create some empty files. So let me okay, so now I have file 1 file 2 added over here. So this is my project और with time these files will evolve, right? So मेरा first purpose क्या है कि मैं इसको गिट के jurisdiction में लेके आऊँ और गिट फिर उसके बाद अपना काम चालू करेगा, which is tracking changes on these files, right? So what I have to do is basically this, right? So this is the shortcut for current folder, and what I'm saying is, what I'm asking Git to do is start tracking this folder. So जब मैं ऐसा करता हूँ तो क्या होता है, ये वर्किंग फोल्डर जो है गिट के जुरिस्डिक्शन में आ जाता है, राइट। और इसका इम्पैक्ट ये होता है ना कि इस फोल्डर में एक .git नाम का हिडन डायरेक्टरी बन गया है, राइट। What this will have is all the information, all the bookkeeping information that is required to track changes of this directory. Okay, so अभी मेरा ये jurisdiction में आ गया है git के, right? Now what I want to do is I want to track changes of the files. सिर्फ इतना करने से मेरा git फोल्डर बन गया है, बट अभी भी कोई फाइल जो है ट्रैक होना शुरू नहीं हुई है। तो उसको करने के लिए मेरे को क्या करना होता है, अब ये वाली जो फाइल है वो क्या हुई, ट्रैकिंग के अंडर आ चुकी है, राइट। अभी मैं इसका कंटेंट देखूंगा तो क्या है, कुछ भी नहीं होगा, राइट, बिकॉज आई हैव क्रिएटेड एन एम्प्टी फाइल. Let's say that I add some content to it, right? So okay, now what is happening is एक line इसमें add हो गया, right? Now since this was under tracking, what will happen is Git will tell me that this file has been modified after the tracking started. अब मैं इसको अगर git diff करता हूँ तो मेरे को बताएगा अभी क्या चेंज हुआ है. After tracking started, I added one line, and this is that. Okay, so if we go into this figure, what is happening is I have moved my folder under the jurisdiction of Git. उसके basis पे क्या हुआ, वो working folder बन गया, right? And after that I added some files जिसपे मैं tracking लगाना चाहता हूँ. तो मैंने क्या किया, उस फाइल को मूव किया स्टेजिंग एरिया में और उसकी ट्रैकिंग शुरू हो गई, राइट. सो लेट्स लुक एट सम मोर कमांड्स जो वर्किंग फोल्डर और स्टेजिंग एरिया के बीच में काम करती है, राइट. मैं बीच में चेक करना चाहता हूँ कि मेरा स्टेजिंग एरिया और वर्किंग फोल्डर का क्या स्टेटस है, राइट. सो वो मैं कैसे करता हूँ, नाउ दिस इज टेलिंग मी ये जो एरिया है बेसिकली ये वाला जो एरिया है मेरी लोकल रिपोजिटरी का बताता है, राइट. दिस एरिया टेल्स मी अबाउट staging area, and this is basically what my working folder. Okay, now let's say that I want to commit whatever is in my so I update this changes, and now I commit, right? So commit करने से क्या होगा कि जिस जो भी फाइल्स ट्रैक हो रही थी दे विल गो इनटू लोकल रिपोजिटरी. लोकल रिपोजिटरी क्या है? वो सारी चीजें हैं जहाँ पे हर एक फाइल का हिस्ट्री भी मौजूद है. ओके, जस्ट हेलो, just wanted to confirm you are following it, right? Whatever discussion has been happening so far. Is there any doubt? Can you respond in chat? Okay, so I'm assuming no doubt so far. Yeah, so अभी तक हम जो भी कर रहे थे, we are moving from working folder to staging area. Working folder where which is under the jurisdiction of Git, right? Staging area is a subset of working folder where tracking has started, right? So all the files that has been moved to staging area, उनका tracking चालू हो गया, right? Now how do we move from staging area to local repository? So we use this command commit. So अगर मैं क्या करता हूँ यहाँ पे कर देता हूँ, okay. Now when I do git status, what is happening? That file has gone from my staging area to local repository. Okay. अब मेरे पास बचा गया है मेरा वर्किंग फोल्डर और इसमें एक फाइल है जो अभी भी ट्रैक नहीं हो रही है एंड इट इज टेलिंग मी दैट. ओके, सो we have already seen diff, we have already seen status add in it, right? These operates when we are dealing with working folder as well as staging area. Now let's talk about staging area and local repository. So what is happening when I committed? What happened? First snapshot of my entire project got created. Okay, now when I do git log, एक एंट्री यहाँ पे तैयार हो गई. This is one point of time where I can revisit in past. Okay, so although we are doing time traveling, we can't travel to every moment. We can travel to certain point of time. और वो point of time हम कैसे define करते हैं? Via commits. जो भी commits होते हैं, they are properly time stamped and they are properly hashed, right? ये उस commit का entity है. Think of this like this is the address of that point of time where we can go, right? So let me do one thing. Let me add this file also. Okay, now what do I have? I have 2 point of time where I can go back. This is currently my head, like this is the present, and this also have a hash, right? Now if I want to go back in point of time, what I'll do is okay, and now it is telling me you are no longer in present, you are somewhere in past. तो मेरा head जो है वो detach हो गया है अभी. My head is not in present, I am living in past, right? So and this is the address of that commit, right? So and now I am back in present. So let's say अगर मेरे को किसी वर्किंग उसमें जाना है और प्रोजेक्ट को इन्वेस्टिगेट करना है, what I'll do is git checkout commit ID and I am back in time in that particular state of project. So this is how I am traveling from staging area to local repository. यहाँ तक का जो भी काम होता है ना, think of it like I'm a solo developer and I just want to track changes of my files I want to see what I did some time back, right? Now comes the part where I want to collaborate with other people. I want to share, right? Any software project success depends on one is collaboration, another is feedback. If we show that to better developers, they will suggest changes. You can make those changes, right? All that is only possible when you can share your code effectively with them. और वहाँ पे क्या होता है हमारा what comes into picture? Let me just yeah. So what is happening is, as far as it is in local repository, it is on my machine, right? Now, in order for me to share it with other people, what I need is a remote repository where everyone will commit their changes and all that, right? आमतौर पे वो remote repository कहाँ पे होता है? GitHub पे. But GitHub is not the only platform that is based on Git. GitLab is also based on Git. सारी Git commands जो हमारी GitHub projects पे चलती है, वो GitLab पे भी चलती है. And I think Bitbucket पे भी चलती है, right? So GitHub is like a hub, like house for all the Git based projects. Okay, so GitLab is also that. So GitLab came afterwards and is now also popular, but for all open source projects, GitHub is still the first preference. Okay, so now I'll do what is, I'll go over here. I want to move my folder, my code from my local repository to remote repository. But उससे पहले मुझे क्या करना होगा? Remote repository बनानी होगी. So what I'll do is, I'll do okay. जैसे ही मैं बनाता हूँ ना, ये मेरे को दो सजेशन देता है कि अगर आपके पास पहले से नहीं है कोई रिपोजिटरी, लोकल रिपोजिटरी, यू फॉलो दीज स्टेप्स. इफ यू ऑलरेडी हैव, देन फॉलो दीज स्टेप्स. तो हमारे पास ऑलरेडी है, गिट से ट्रैक भी हो रही है. हम क्या करेंगे, ये वाले स्टेप्स फॉलो करेंगे. सो लेट्स से आई डू दिस. व्हाट आई एम डूइंग इज, पहली चीज तो मैं रिमोट से बाहर जाके लोकल से बाहर जा रहा हूँ रिमोट में, राइट? सो ऑन रिमोट आई एम एडिंग अ रिमोट रिपोजिटरी, राइट? बाय डिफॉल्ट उसको क्या कहा जाता है? ओरिजिन, राइट? एंड दिस इज द पाथ. सो अभी क्या हुआ, आई हैव सेटेड अप रिमोट रिपोजिटरी फॉर माई लोकल वर्क. ओके, सो अब मैं क्या करूंगा, I am in main, okay, and I'll have to do what? Okay, and what I have done over here is I have moved my git tracked code to remote repository. Okay, and here I'll have file1, file2.md. Okay, so this is the journey of my work from local repository to remote repository. So far, is there any doubt? Okay. Cool. So no doubt so far. So अभी हमारा जो जर्नी है वो कहाँ से कहाँ तक पहुँचा है, हम रिमोट रिपोजिटरी में अपना कोड भेज पाए, राइट? नाउ लेट्स से दैट देयर इज सम अदर पर्सन इन्वॉल्व्ड व्हिच इज एडिटिंग द फाइल ऑन रिमोट, राइट? या अपने लोकल पे वो एडिट करके रिमोट पे पुश करता है, राइट? सो आई विल सिमुलेट दैट जस्ट बाय एडिटिंग द रीडमी फाइल ओवर हियर. सो आई विल गो हियर, add a readme file. Okay, readme file is a markdown file. इसका अपना एक सिंपल सिंटेक्स होता है. We can also preview it how it will look, right? और मैंने ये पुश कर दिया है. Okay, so now what is happening is my remote repository is ahead of my local repository. So what I'll do is I'll pull these changes पुल का मतलब है आई एम पुलिंग कोड फ्रॉम रिमोट रिपोजिटरी. ओरिजिन क्या बताएगा, जो मैंने अभी सेट किया है ये, राइट. सो इट विल टेल कि यहाँ से उठा के मेरे को अपना कोड लेटेस्ट कोड लेके आना है. मेन इज द ब्रांच इन विच आई एम getting it. So when I do this, I also end up with readme file, and now my local repository is, this is my local repository pointer, this is my remote repository pointer. They are pointing to the same commit, right? So that is what सो लोकल और रिमोट रिपोजिटरी के बीच में ऐसे आदान प्रदान होता है, राइट. अगर मैं पुश करना चाहते हो अपने चेंजेस, तो आई डू git push origin main. Origin will tell किस URL पे भेजना है, main will tell which branch, push will tell that data is moving from my local repository to remote. Same thing, I just changed push to pull. What is happening? The flow of data has changed. अगर दोनों सेम ही पॉइंटर पे है, then nothing will change. Otherwise, new data will come to my machine. Now what happens is, sometimes there is already a git tracked repository on GitHub. How do I get it back on my machine? So over here what we have is this thing, right? Code. यहाँ से ये URL कॉपी करते हैं और अपने सिस्टम में क्लोन कर लेते हैं. Then what happens? इसी के corresponding to this remote repository, a local repository gets created on my local machine, right? And then everything works in the same way. अब थोड़ा tedious part आता है. Not exactly tedious, but it requires some getting used to. Now that we have gone to remote, right? We also have version of our project on remote repository. It opens the possibility of collaboration. So now what people can do is, different people can clone this repository from remote URL, okay? And then they can start contributing to that remote repository. So when they want to contribute, what can happen is that this is our main branch, uski commits, right? Now I can work on some other feature, some other guy can work on, some other person can work on some other feature, right? अगर वो मेन पे ही काम करते रहते हैं, then there is a risk of interfering, right? मान लो कि मेरे पास ये ऑप्शन नहीं था कि मैं ब्रांच क्रिएट कर पाता, राइट? सो व्हाट आई वुड हैव डन इज, मैं थोड़े चेंजेस करता अपने और पुश करता, राइट? अब ये बंदे ने ऑलरेडी मेन ले रखी है, राइट? मेन पे वो काम कर रहा है और मेरे चेंजेस अभी उसके साथ इंटरफेयर कर रहे हैं, राइट? सो ही डजंट हैव अ कंसिस्टेंट सोर्स ऑफ ट्रूथ टू वर्क ऑन, and that's the reason why we have branches. What branches does is, if I create a branch from here, what will happen is I'll branch off the main path, okay? And my new branch will have all the history that main had, but now my present is running on a parallel timeline, okay? I am building my future, feature slip of tongue, yeah. So also future, but for now feature. So I'm building the feature, and when it is done, what I can do is I can push it, merge it into main branch. Now what happens is, as long as I was working on my branch, I had a consistent view of the source of truth, right? जहाँ से मैं शुरू हुआ था, मैं उसके ऊपर ही build कर रहा हूँ, right? Likewise, this person can start from here and build its own feature and again merge it back to main. So इससे फायदा ये होता है कि there is a, for time being, there is a source of truth on which development happens, right? And they don't interfere with each other. The only problem comes when they merge, right? So there is a possibility there are merge conflicts. This person made changes on the same file or same lines which this person made, and then there is some mechanism on how to handle merge conflicts. So merge conflicts abhi nahi dekhenge. Why? Because you can simply avoid merge conflicts by pulling the latest code while you are starting to code, right? And by being friends to all your colleagues so that they keep you informed that they are also making uh, changes to some files which you are also working on, right? But I would say this is how we can create a branch. So let's say that I want to create another branch here. So I can do right. So now I have how many branch? Two branch. And now I'm currently on which branch? Feature. Whatever changes I make, it will not corrupt the main branch. It will stay here unless I choose to merge feature branch back into main, right? So let's say that I add another file. Okay. What will happen? Excuse me. So यहाँ तक हमारा क्या था? Main branch था. उसके बाद we created a new branch, and this latest commit went into which branch? Feature, not in main, right? Now I can push this branch as it is to जब भी कोई डेवलपर जो है पुश करता है तो यहाँ पे क्या आता है? ये नोटिफिकेशन आ जाता है, right? Now what I can do is, let's say I am the maintainer and someone else has pushed this feature branch. तो मेरा व्यू क्या होगा? This is the developer who pushed the feature branch, उसके एक्शन से, राइट? वो क्या करता है? एक पुल रिक्वेस्ट ओपन करता है और मेंटेनर से ये रिक्वेस्ट करता है कि मेरे चेंजेस जो है मेन में शामिल किए जाएं, राइट? ये उसका फॉर्म है, यहाँ पे कमेंट्स लिख के ये सब आ जाता है वहाँ पे, राइट? Now since I am the developer who pushed it and I am also the owner of this repository, I am also getting the maintainers options, right? Merge pull request. Merge pull request करने से पहले what I can do is I can investigate the changes that the other person has done, right? So here this file was added और इसमें hello branch की line add हुई है. मैंने ये changes review कर लिए, right? I am okay with those changes. What I do? Okay. Now what happened over here? Feature 1 का जो commit है वो यहाँ पे merge हो गया. This is the commit the developer did and this is the merge step that has happened, right? And now what I can do is I can pull the latest changes. So I can see main is one step ahead of feature branch. This one step is basically what? The merge step. Okay. Now मेरा feature branch का काम हो गया है. So what I can do is I can just get rid of feature 1. And now I am again left with main branch. So this is about the journey between local repository and remote repository. Okay. Pull request हमने देख ही लिया है क्या होता है. Now whatever we have discussed so far is basically what 20% of all there is in GitHub, right? But as per Pareto principle, 20% of the things get 80% of the things done. If you are aware of these things, you are 80% sorted, right? Those 20% you will learn along the way. Okay, so there are other things which you can do with GitHub. So अभी उसको देखते हैं, right? So there is this software, I would say library called mkdocs. MK डॉक्स की उत्पत्ति जो है वो इसलिए हुई थी कि वो डेवलपर्स के लिए आसान बनाना चाहते थे अपने प्रोजेक्ट्स का डॉक्यूमेंटेशन होस्ट करने के लिए, राइट? सो इट्स कॉल्ड MK डॉक्स, मेक डॉक्स ऑफ your GitHub projects. Okay, so this is how you install MK docs. What we are going to show is, okay, यहाँ पे मैंने GitHub लिखा है, GitHub है ये. So what MK docs does is कि अगर आपका MD फाइल्स बनी हुई है ना, मार्कडाउन फॉर्मेट में फाइल्स बनी हुई है, उसको नीट HTML फाइल में कन्वर्ट करके वो होस्ट कर देता है. सो अभी उसको लाइव देखेंगे. लेट्स सी हाउ इट हैपेंस. सो लेट्स से मेरे पास ये फोल्डर है, राइट? और मैंने डॉक्स में अपना MD फाइल्स डाली हुई है, राइट? सो व्हाट आई कैन डू इज I can just run MK docs in this folder. MK docs ने क्या किया यहाँ पे, ये MK docs.yml फाइल बना दी, राइट? और अब अगर मैं MK docs सर्व करता हूँ तो उसने मेरे कोड बेस का क्या कर दिया है, वेबसाइट बना दिया है, राइट? नाउ आई कैन गो इनटू फाइल 1, फाइल 2, फाइल 3, hello branch, right? All this is coming, okay? And I am able to do this just by writing MD files, right? So project build karna is one thing. You can also build homepage for yourself just by writing MD files without any heavy lifting in HTML, JavaScript and all that, right? I'll give you an example of a website that we have built in just MK docs. All these are just MD files. Just by writing simple text MD files, we are able to create websites which are decent, right? बहुत ज़्यादा fancy भी नहीं होगी, but we are able to operate, right? So ये तो हमने क्या किया, लोकल पे कैसा दिखेगा ना वो हमें क्लियर होगा, राइट? सो व्हाट वी कैन डू ऑल्सो इज वी कैन होस्ट इट ऑन GitHub pages. What are GitHub pages? GitHub pages allow developers to deploy static pages, right? So if I do this, what it did was इसने यहाँ पे एक ब्रांच बनाई है GH pages की, right? And soon it will be available to us over here. So I've already done this with while preparing for this slide. So ये देख लेते हैं, right? Same thing, just where on GitHub pages, right? So it is free of cost. You don't have to buy a domain or anything, right? So you can actually create your homepage. You can list down your projects in MD files, and then just do MK docs deploy, and your homepage will end up over here, right? ankushchander.github.io. It is kind of easy to remember, right? Your name.github.io, and you will find your homepage hosted with just simple clicks. So this is just one of the use cases of MK docs. I encourage you to build homepage, like at least and upload your latest projects over there so that you can share it with on your resume, share it with people, and they can just check out your homepage, right? So this was about MK docs. Now what are some of the GitHub tips that you can leverage? So one is that आपका जो GitHub का account होता है ना, उसमें this is your home page, right? And where is this home page? What I have done is Ankush Chander, what is my username, उसके नाम का मैंने एक repository बनाया, और उसके अंदर जो readme.md है, वहाँ पे जो भी मैं changes करता हूँ, they all end up where? On my profile. So whenever someone lands on my profile, that readme content is displayed over here. So this is one of the things, if you maintain, right, then this also becomes a kind of your banner, kind of, right, where people come and see what are you interested in, what kind of projects you are building and all that, right? Second thing is activity log, right? So this is something that recruiter often look at just to gauge in how much active you have been. और इसमें ये setting होता है private contribution. So sometimes what happens is that you are working on private projects and you can't share the code. It is not public. Then what you can do is you can enable private contributions. उससे क्या होता है कि whatever private projects also you are maintaining on GitHub, that activity also come over here. Just the count, right? And this look little colorful, right? A lot of people say that this is a vanity metric. इसको हमें chase नहीं करना चाहिए, all that, right? And they show big programmers, right? एक ने तो C++ के जो जिन्होंने बनाई है उनका GitHub प्रोफाइल दिखा दिया, खाली है, राइट? अब इनको क्या बोलोगे, ऑल दैट, राइट? बट when are out there job hunting, make sure that this has something in it, right? To give recruiter an early signal that you are an active programmer. Okay, इसका मतलब ये नहीं है कि हर दिन जो है अपडेट रीडमी करोगे और इसको पूरा हरा बना दोगे, राइट? Whatever projects that excite you, make sure that you put it on GitHub, share it with other people. So that is something that I encourage you to do. You can add your LinkedIn, Twitter, Stack Overflow profile also on your GitHub, and do vice versa also. Your LinkedIn should take people to your GitHub profile. GitHub should take you to your professional LinkedIn profile. So you can add it over here by editing your profile. Okay. So yeah. So what is worthy of being put on GitHub? Anything, right? To start with, just to come into the habit of just push anything, right? As long as it doesn't breach the privacy of the institution that you are part of, you can push anything, like the assignments that you are working on, or some small toy project that you are working on, or some problem that you solved and you liked how it came out, right? The solution came out. You can just put it on GitHub for others to see, right? You can also share the link of that with people who you think are, would be interested in giving you feedback. So this is a suggested follow-up read, How to Become a Hacker by Eric Steven Raymond. So years ago, when I was having doubt whether I belong to this field or not, whether I should be continuing my career in programming, I came across this article and it helped me, right? And I often reread it, and each time I reread it, I come out with something different each time, right? So this is the article. It's very old. If you see how long it goes back, yeah, 2007, right? So read it. Why I've put it over here is because Git and GitHub is all about craft, owning your craft as a programmer, right? It is about just a minute. Yeah. So it is about owning your craft. It is about collaborating. It is about seeking feedback from other people. It is about community. This article roughly talks about everything, right? How to be a good community member, how to pursue your craft, how to pursue problem solving, कैसा mindset रखना है, right? How to behave in community, all that. So just give it a read. It should take more than half an hour to read it up. So that's a follow-up read. These are the references. At least GitHub blog का जो वो है, just follow it, and a lot of interesting programming articles comes over there. This is one of them, like how to make your GitHub profile page accessible by other people. This is a freely available book जो ना सिर्फ हमें ये बताती है कि Git यूज कैसे करना है, उसके इंटरनल्स में भी ठीक ठाक विजिबिलिटी हमको देती है, राइट? MKDocs documentation, just to host your web pages for free on internet. So yeah, that would be it. Do you have any questions?